circle. You guys are going to be able to learn how to find values of trig functions for any angle, okay? Any angle possible. Your first introduction into a little bit of the unit circle. We will actually go full head on into the unit circle next class, okay? So, you are taking these notes by hand, okay? Smart notes. And everybody has a little pad of graph paper. Basically, that pad is going to serve for our examples that we do dealing with this topic, okay? So, to find your trig ratios when you're given an ordered pair, okay? As we know, an ordered pair is a point that is plotted in your x and y axis, okay? And then it creates an angle because your terminal side goes through that point, and of course your initial side is fixed to the x-axis, okay? So that angle that is created is the angle that's formed between that terminal side going through that point and then the initial side, okay? So basically you're finding the trig ratios for that angle that's created there. Do you guys see? Okay, so the steps that go with finding these trig ratios. Step 1, of course, graph the ordered pair. You want to graph the ordered pair because you basically need to know what quadrant you are in. The quadrants do matter. Step 2, you want to drop a perpendicular to the x-axis. Perpendicular. That's a vertical line that goes to the x-axis to create what type of angle?
Right angle.
A right angle, a 90-degree angle, okay? So basically between the terminal side and that perpendicular line that's drawn to the x-axis, you create a right triangle. Then, of course, you want to label your triangle with the information that you're given, okay? One thing I want you guys to look at, so go ahead and take a moment to look now, is that when you create that perpendicular with the x-axis, you create this right triangle. This distance right here is the x-coordinate of your point. How far along the x-axis did you go? And then this side, that perpendicular side, is the y-coordinate of your point because that's how far down you went or how far up you went. So when they give you the coordinate, they actually give you the two legs of your right triangle. Okay? They give you your two legs of your right triangle. So that's what I mean by label the information. Then step 4, you want to use the Pythagorean Theorem to find the hypotenuse. That's going to be the only information that you do not have. Okay? The formula to find the hypotenuse, of course, Pythagorean Theorem is what? A squared plus b squared equals c squared. In this particular case, it's technically x squared, which is one of your legs, plus y squared, which is the other leg, equals r squared. Okay, because r represents the hypotenuse, it basically represents the angle of the terminal side. And then, of course, you find the ratios. So these are the same ratios, these are the same opposite and adjacent, opposite and hypotenuse, et cetera, that we had before. It's just in retrospect of an ordered pair inside of a coordinate plane. As we can see, hopefully you haven't forgotten from the first lesson of this unit, cosecant is the reciprocal of sine, that's why it's r over y. Secant is the reciprocal of cosine, that's why it's r over x. And cotangent is the reciprocal of tangent, which is x over y. Those do not equal, just let you know that your denominator should not equal 0, because what happens if your denominator equals 0? What happens if your denominator equals 0?
It's undefined.
Thank you. It's undefined.
I think of the word.
Undefined. So let's look at our first example, okay? Our first example is -9, 9. Okay, first example is -9, 9. We are basically going to find the 6 trig ratios for this angle. Okay, so -9, 9 is located in what quadrant?
Where? 3.
2. In 2. Okay, so -9, 9 means your x coordinate is -9 and your y coordinate is +9. So that means I'm going to go 9 along my negative x axis. So 1, 2, 3, 4, So negative 9. And then I'm going to go up 9. Okay? So I apply my ordered pair. Step 2 says to drop down the perpendicular. Okay? Step 2 says to drop down the perpendicular. I need to create my triangle. Okay? My triangle is formed by drawing the hypotenuse back to the origin. And I need to label this triangle. Bless you. This side down at the bottom. How long is this side at the bottom?
9.
It is 9, but since we're inside of a coordinate plane and we went 9 to the left, it's actually going to be a negative 9. Yes, the signs do matter. What about your perpendicular side? Positive 9. So then the next step says we have to figure out what is the hypotenuse. So that is r squared equals x squared plus y squared. Well, then that's going to be nothing but negative 9 squared plus 9 squared. So that's 81 plus 81, which is what? 162. Now, is 162 a perfect square? No. But what numbers do go into 162 evenly? Are any of them perfect squares? Check your perfect squares. See if this simplifies. So this breaks down to be the square root of 81 times the square root of 81 times what gives me 162? 2. So then this is going to be 9 square root of 2, and then that is my hypotenuse. Also, what kind of a triangle is this?
Oh, this is like the 45, 45. So then it would be
So it would have been the
x
legs.
square root of 2.
This was a 45, 45, 90 because the legs, even though one is negative, they're technically the same length. So that's why it's 9 square root of 2. The angle theta that we're going to use to find the remaining, the 6 trig functions is the angle that's, of course, inside the triangle. Okay? It will give us the actual trig functions for the angle that goes through 9, negative 9, here, that's in blue. Okay? We use the inner angle for this, yes. But essentially what we are finding is that blue angle there. That's technically what we're finding, the 6 trig ratios of that blue angle. So that's going to be sine theta, cosine, tangent, and then the reciprocal functions, cosecant, secant, and cotangent. The same things that we did back in the very first lesson, we are doing here. We're applying it into a coordinate plane. Sine is what over what?
Opposite of the hypotenuse.
What's my opposite side?
9.
The 9. What's my hypotenuse?
9 times square root.
So I have 9 over 9 square root of 2. Can I simplify that?
You don't have to go with it. I'm going to multiply it by 9.
Well, this simplifies first to 1 over the square root of 2, and then I can simplify that, can I not? Because I cannot have a square root in the denominator, so rationalize, so I get the square root of 2 over 2. Cosine theta is what over what? So this has to be my adjacent side because I've labeled the other two sides. So cosine theta is going to be negative 9 over 9 square root of 2, which simplifies as well to be negative 1 over the square root of 2, which I'll have to rationalize as well and get negative square root 2 over 2. Does anybody actually need to do the rationalization work? What about tangent? Tangent is what over what? Opposite over adjacent, so it's 9 over negative 9, which is just negative 1. Now let's do cosecant theta. Cosecant is the reciprocal of which one? Sine, so that means I need to flip sine. And if I'm going to take it from my work I've already done for sine, you want to take it from the non-simplified answer. Because if you take it from the simplified answer, you're going to end up having to rationalize again. Okay? So if you want to save yourself some time and save yourself some work, or you can always base off the original triangle. So if I flip it, I'm going to flip that 1 over the square root of 2. And when I flip that, what does it become? Square root of 2 over 1, right? Just square root of 2. Secant is the reciprocal of cosine, so I'm going to flip that non-simplified form. So what does that become? Square root of 2 over negative 1, which becomes what? Negative square root of 2. What about cotangent? I have to flip tangent, so that's just going to be what? Still just negative 1. And those are your trig functions for the ordered pair 9, negative 9, 9. Literally almost the same thing we're doing in 5-1, but now we're just incorporating it into a coordinate plane to lead us into the unit circle. Questions? That sign does matter because in your second quadrant, your x's are negative, but your y's are positive. Okay? So it does matter. One thing that you need to remember is that all students take calculus. This right here is going to help you remember which trig functions should be negative or which trig functions should be positive when you plot these ordered pairs. Okay? If you have an angle that's in the first quadrant, that means that all your trig functions are going to be positive, hence the all. So that means that sine's going to be positive, cosine's going to be positive, and tangent's going to be positive. Every single one of those is positive, and of course, they're reciprocals as well. Hence the all. Students. Student starts with a what? So that means that sine is the positive angle. And it's reciprocal. What's the reciprocal of sine? Cosecant. Its reciprocal is also positive. You can look at the last example we did. It was in the second quadrant. Sine and cosecant were the only positive trig ratios. Take starts with a, which means that tangent is going to be your positive trig function, and its reciprocal, which is cotangent. Okay, it's to help you in remembering which trig function should be positive, especially students tend to lose the negative as they're going through. And the last one is calculus, which starts with a, just like, so cosine is your positive angle, and its reciprocal, which is secant. Okay, so all students take calculus will help you remember which trig function should be positive, which one should be negative. Okay, and just to recap, all is what quadrant? Students is take calculus. Questions on that? I want you to try the next one on your own. Find my 6 trig functions. What quadrant is -2, -1 in? 3. So I go -2 and then -1. So then my angle is very tiny inside of this triangle and is located here. Okay, remember your angle is always, in this case, is always located with your x-axis and your hypotenuse. Okay, so this -1 was your what side? And your -2 was your adjacent. And then, of course, the side across your 90-degree angle is your hypotenuse. What did you guys get for your hypotenuse? Square root of 5. If it can be simplified, you simplify, but if you can't, you just leave it how it is. So running down the 6 trig functions, sine was what over what? You do need to rationalize, so what is that? Cosine. So that would be -2 square root of 5 over 5. is the reason why I'm writing the non-simplified answer and then the simplified answer. Okay? Tangent theta. Negative 1 over negative 2, which simplifies down to be positive 1/2. Okay? Reciprocals, cosecant is negative square root of 5. Very good. Secant theta. Okay, let's talk about that. Square root of 5 over negative 2. That's the same thing as saying what? And it makes the entire fraction negative. Okay? So just because it's in the denominator, just in the numerator, the entire fraction is negative. Okay? And then the last one, cotangent theta, would be just a positive 2. Very good. Just to double check, in the third quadrant, all students, is tangent and cotangent the only positive answers you have?
Yes.
And you did good. Very good. Okay? Yes.
What happens, like, are you going to mark off if we draw our triangle wrong? Because, like, I do it, like, the opposite way. I got the same answers.
Yes. Especially if I ask you to draw it, it should be drawn in the correct manner. Why did you draw it perpendicular to the y-axis?
I just, like, do, I don't know.
Okay. Make sure that it is in the correct quadrant, and then it is perpendicular to the x-axis, so be careful about that. That's why you plot the point first and then drop down the perpendicular. Okay? Let's do one more of these. What quadrant is negative 4, 3 in? 2. Negative 4, positive 3. I drop down my perpendicular to which axis? The x-axis. Then I create my triangle and label my information. This is negative 4. This is positive 3. R squared equals 3 squared plus a negative 4 squared. When you square a negative number, it's always, so 16 plus 9 is equal to what number? And what's the square root of 25? Your radius, I'm sorry, I'm foreshadowing. Your hypotenuse is 5, always positive. And when I run my 6 trig functions down, I won't have to worry about any rationalizing because I have all whole numbers.
Oh, heck yeah. Okay.
Which is the opposite side in this picture? 3, adjacent, negative 4, and hypotenuse. So when I get my 6 trig functions, it's pretty straightforward. Sine is going to be 3 over 5. Cosine is going to be a negative 4 over 5. Tangent is going to be a negative 3 over 4. Not a 3 over a negative 4, because a negative in any part of a fraction makes the entire thing negative. Cosecant is the reciprocal of, so what's the answer? Very good. Secant is the reciprocal of cosine, so that's going to be negative 5 over 4. And cotangent, negative 4 over 3. Very good. Questions on the ordered pairs? So, real quick, if the terminal side of an angle is in standard position and it lies on one of the axes, it's called a quadrantal angle. Okay, it's called a quadrantal angle. Which basically means when you go through and do your 6 trig functions for these quadrantal angles, some of them will be undefined. Some of them could be 0. It really just depends on which axis it's on. Okay? One benefit about your quadrantal angles, like I said, is either it could be 0, it could be undefined. It really just depends. And if you notice in every single one of these quadrants, your first, your second, your third, your x positive x-axis, your positive y-axis, your negative x-axis, or your negative y-axis, depending on which one, depending on where it is. You see how each point is either R0 or 0R for the negative versions? That R is the same R from those 6 trig functions from the first slide. Okay? This R is the same R that you would get if you did x squared plus y squared, square root. Okay? So if you're given the ordered pair 4, 0, and you're asked to find the 6 trig functions of 4, 0, you can't make a triangle here because it's in the first quadrant. Okay? But you can find the 6 trig ratios. Sine is x over r. What's the x coordinate? 4. What's the y coordinate?
0, 0.
What is r?
2. 0, 4.
It's 4. That point, because it's at 4, 0, that 4 corresponds to r as well. So sine, which is x over r, is 4 over 4, which is what? 1. Sorry, I had that backwards. I'm sorry. Sine is not x over r. Sine is what over r? Look at your notes. Y over r. So that was my mistake. Y is 0. R is 4. What's 0 over 4?
0.
Cosine is x over r. So that's 4 over 4, which is equal to what?
1.
Tangent is what over what? So y over x was 0 over 4. 0. So all my answers are either going to be between 1 or 0. And because it's in the first quadrant, all of them are going to be positive. Cosecant is the reciprocal of sine. When I flip sine, that's going to give me a 4 over 0. What's 4 over 0? It's undefined. So cosecant is undefined. Secant is the reciprocal of what? Cosine. So when I flip 4 over 4, it still stays as a 1. Cotangent is the reciprocal of tangent. What happens when I flip 0 over 4? So when it comes to quadrantal angles, like how I've just showed you here, you just have to make sure that you're careful and you remember sine is which over which. And you also have to remember that the ordered pair that's given to you, that value is also your r. One last example, even though I actually had 2 more examples, but I'm out of time here. These were like how 5-1 was. When I give you one of the trig functions, tangent theta equals 5 over 12, where sine is less than 0. We're going to find the exact values of the 5 remaining trig functions. You're going to do this in your little booklets. Okay? So tangent theta is 5 over 12. 5 over 12 is a positive number. What quadrant is tangent positive? Tangent is positive in quadrants 1 and quadrants 3. So what quadrant is the triangle going to go in? The first or the third? You use this other little bit to help you. Where out of quadrants 1 and 3 is sine less than 0, aka where sine is negative? Is it the first quadrant or the third quadrant? Third. So you're going to draw this triangle in the third quadrant because that's where the 2 overlap. Where tangent is a positive and sine is a negative. So third quadrant, where the x value is technically it's a -5 and the y value is it's a -12. In the third quadrant, aren't both coordinates negative?
Yes.
But when you divide a negative by a negative, doesn't that give you a hence why tangent is positive? those signs are going to make a difference because you're in the third quadrant. Your x and your y are negative. And when you divide them, it gives you a positive. Hence, y tangent is positive. When I do Pythagorean Theorem, I get my hypotenuse to be 13. And I know this because I know my Pythagorean triples, but of course, Pythagorean Theorem if you need it. So when I do my remaining 6 trig functions of sine, cosine, cosecant, secant, and cotangent, I have all my information to do so. But the main thing was that I needed to know which quadrant I was in to make sure I don't mess up on the signs. Sine is what over what?
Opposite. Oh, yeah, opposite of hypotenuse.
Where's my theta? Is it down here at the bottom? It's up here. So negative 12 is my opposite, negative 5 is my adjacent, 13 is my hypotenuse. So that's going to give me negative 12 over 13. What's my cosine? So negative 5 over 13. Cosecant is the reciprocal of, so this is going to be a negative. Very good. Secant is the reciprocal of cosine, negative 13 over 5. And cotangent is the reciprocal of tangent, which was given to us. So if anything, you should at least get 1 out of the 5 right, because I give that one to you. You got to remember to flip it. And I gave you another one that was similar, but we're pretty much out of time at this point. But that is how you find trig functions in the unit circle. You're going to see all these variables and everything again on Thursday when we actually get to the unit circle. So for this last example, we have secant theta equals the square root of 3, where tangent theta is less than 0. So first off, we know that if secant is positive square root of 3, that means that cosine has also got to be positive. Well, in our quadrants, cosine is positive in the first quadrant and the fourth quadrant. And it also says that tangent has to be less than 0, which means that tangent has to be negative. Tangent is negative in the second quadrant and the fourth quadrant. So where do the two overlap? The fourth quadrant. So that means when we draw our triangle, our point, it's going to have to be in the fourth quadrant. Now, more specifically, since we're given that secant theta equals the square root of 3, is the same thing as square root of 3 over 1. Now, we know that secant is r over x, and so we can use that to plot, to basically create our triangle. So since x is 1, we know that that piece there is going to be 1, and then we know that the hypotenuse is going to be the square root of 3. So now we're going to have to use Pythagorean Theorem, but this time instead of looking for the hypotenuse, we are going to be looking for the value of y. So then that's going to be 1 squared plus y squared is equal to the square root of 3 squared. So this becomes 1 plus y squared is equal to 3. Y squared is equal to 2. So then you take the square root and you get y is equal to the square root of 2. But because it's in the fourth quadrant, y is going to be negative. So now we have that r is the square root of 3, x is 1, and y is the square root of 2. We can find the remaining 5 trig functions, which are sine, cosine, tangent, cosecant, and cotangent. So sine is y over r, so it's going to be negative square root of 2 over square root of 3. We do have to rationalize this, so it's going to be multiplied by the square root of 3. And when you multiply radicals, you multiply the normal way. Square root of 2 times the square root of 3 is the square root of 6, all over 3. So that becomes negative square root of 6 over 3. Cosine is the reciprocal of secant. So since we know secant is square root of 3, it becomes 1 over the square root of 3, which again we rationalize, and we get square root of 3 over 3. Tangent is y over x. That's the square root of 2 over 1, which is just negative square root of 2. Now for the reciprocals. Cosecant is the reciprocal of sine. So I'm going to flip negative square root of 3 over square root of 2. Again, I'll have to rationalize, and this is going to give me negative square root of 6 over 2. And then cotangent, I flip tangent, which is going to be negative 1 over the square root of 2, which if I rationalize, it's going to give me negative square root of 2 over 2. Okay? And this is how we find the trig functions for values that are on the unit circle, inside of a coordinate